I work for SARDI, which is the sort of the research arm for PIRSA, and I've worked with industry in these questions, the grains and wine industry. So I guess first, this is when Stephen Schneider, the eminent climate scientist, was a thinker in residence in Adelaide. He used this very simple analogy of you can have an argument with a kid on the beach as to what destroyed the sandcastle. Was it the wave or the tide? And you can go backwards and forwards, and something like the current heat event we're having in April, we can have that discussion. Is it a wave or the tide? Obviously, on a rising tide, there are more waves. But basically, it's useful to sometimes think about that. And certainly, farmers that I speak to, backing up some of what Sarah's saying, would certainly, they'd often say, I'm more of a wave man myself. They're sort of very much conscious of the year-to-year variability versus the trends. In terms of extreme events, I think we can look at that from what's happening on the sandcastle. We can look at it from how agriculture has coped with these extreme events and what we've learned. In the end, it's always an extreme event. It is always the wave that destroys the sandcastle. But on a rising tide, we get more waves. A winemaker said to me once, sometimes the dog destroys the sandcastle. So there's other things like commodity prices and so on. We talk about global climate change, but it is delivered to us in immediate events, and the sort of way that they come together. So with drought and then heat waves and so on, and the combinations of these things. So for agriculture, for both the grains and the wine grape industry, you can say drought, the millennium drought, the El Nino of 2015, we can find these events very easily. Excessive and untimely rain, for example, the La Nina of 2010-11. So the wine industry was really hit hard by that very, very wet summer after the drought. So in some ways, the millennium drought was less of a problem when they had water access than suddenly getting hit with having to deal with all that disease and so on. Frost events, we can go back a lot, but just last year there was a November the 4th frost, which had a really big effect in Coonawarra and so on, and a huge effect across Victoria. And in August 2014 we had a lot of very big damage to the wheat crop from a series of frosts there and so on. Heat is sort of interesting. I came to South Australia in 2004, and in that year we had this really interesting meeting with the wine industry saying, we've had this heat event in February 2004 which is having a huge effect in terms of logistics and everything else. What's going on here? And I've got the transcript from that meeting, and one of the things we're sort of saying is we've got to find ways to impose heat waves because we can't wait 10 years for another heat wave like this. Well, we didn't have to wait 10 years. It happened very quickly. So there's been all these events of October 2004 in the wine industry, March 2008, that very, very long, prolonged late November 2009, the first sort of heat wave back in November, January 2013, January 2014, the summer of 2015-16. So these are all events, and we can sort of chase back some of the what's happening with the climate and so on. And so part of this project is to actually make up a list of some of these events and try and understand how we've coped with them, but also what some of the climate events were happening with them. So here are weather and climate risks in the Barossa. You can take this from sort of likelihood and consequence. And so something like frost is a low likelihood but very big consequence. So when you get a serious frost in a late spring frost, or a hail event, these are low likelihood and high consequence events. These are the events typically we insure for. Something like warmer temperature shifting development is happening all the time, and the industry, when we talk with them, would rank that more as a lower consequence but a higher frequency event. Something like heat waves there is sitting there, and it's happening as we go. So we can talk about these different weather and climate risks and how they're interacting. So obviously heat waves is something that in a very short time are increasing, and we're getting more heat waves. In ecology, there's really rigorous scholarship on this whole idea of how do we learn from single extreme events. This is a special issue which has got a whole lot of really good discussion going back from a whole long tradition in ecology of extreme events, not only from climate change, but also just from when a tree falls over, the impact on light coming into that part of the rainforest, and from people looking back at storms a long, long time ago and what it did to the sparrow population and so on. We have much to learn from that in agriculture, but we've had a lot of these events. One of the things we can do in agriculture is that obviously, because it's such a managed system, there's an ability to adapt. We can also impose heat events. We can put a tent up there and pump hot air and see what happens. And there's a lot we can learn about managing grapevines during heat waves. So it's sort of interesting that with heat waves, yes, their likelihood is increasing, but one interesting aspect, when you talk to some people in the riverland, they'll say that actually we're managing heat waves much better now than we were, so the actual consequence of heat waves may be decreasing because we're getting better at managing them and so on. So obviously there's limits to that, and that becomes an interesting question and so on, but there's ways to do that. And one of the aspects of that is the incredibly good prediction of heat waves in a very short time, and the ability of people to irrigate before the event and manage that. But that would be true of home gardens in Adelaide and so on too, I think. So with this project, Forewarned is Forearmed, so a lot of the information from the Bureau at a climate scale time tends to be above or below median. So the chance of being above or below median. This project is able to look at a lot more detail, so looking at shorter time periods, but also more specific aspects. And so just take the example of heat waves. So this is, or even heat events, you can take that top bar there for the quintile. So rather than just talking above or below median, you can break that up and then start looking at the chance of it being really hot and the reduced chance of it being cooler and so on. And so I think that's, that sort of information is potentially of real value in managing these sorts of events. I just want to talk about the sort of complexity of managing these events. So for flowering time of wheat, basically you want wheat to flower around about late September, October in most of South Australia. If it flowers much earlier than that, you don't grow a big enough crop and you won't get a big enough yield. So basically a wheat plant is changing radiation into biomass and then converting that to grain. If it flowers in late October or November, you just run out of water. We're in a Mediterranean climate and you run out of water. So that's basically the balancing act. And you play that game with different varieties and different sowing times and so on. But there's also extreme events which have a big effect in this. If you flower too early, if you flower in August, you can get frosted and you get frost damage. If you flower later, you get heat. And so, for example, there was that 12th of October 2004 event that when you talk to a group of grain growers, they'll all remember that event when it was about 40 degrees in the Mallee and so on. And then recently we've had a run of some very, very hot periods. After that very, very hot day in October, we had a frost a few days later. So these things overlap and so on. So frost and heat play interaction with that. In a project we were working on, this question of, we know that with El Nino, this was a national frost initiative with the Bureau, so frosts are really worrying to the grains industry. So we know with El Ninos that we get more frost, and that stands to reason. Clear sky nights, so we have radiation frost, we have more outgoing radiation, and we get more frost in El Nino years. So this can lead to a sort of conclusion that El Nino's more frosts, therefore we should flower later, if that makes sense. So basically the simple idea, and this work's been done in the 90s in Queensland. There was an argument that we would use these sort of ENSO-based forecasts to shift our flowering time around and choose cultivars for that. I guess that the problem is that things get complicated because an El Nino also means more heat. An El Nino also means less water. And so actually when you run this through a daily timestamp model like AppSim, what you find is that the optimum thing to do in an El Nino is to flower earlier because you're going to run out of water. And so basically in an El Nino, you will take on more frost risk rather than less. You actually push yourself, there's more frost and you push yourself earlier in that flowering window. That's the sort of optimum size. So I guess that sort of speaks to the complexity of these things, of understanding these things having to talk about frost, heat and water, whereas often we break these events down to single aspects and try and talk about single aspects of them. One of the so basically this is a bit of a horrendogram, but for ENSO, or Indian Ocean Dipole, there is an effect on frost, but the correlation with heat is stronger and the correlation with water is even stronger still. And so basically what you find is you get these mixed messages and basically water trumps the other two. So just finishing up, that Lisa Alexander at A Specialist on Extremes says climate science focuses on extremes that are statistically robust and widely applicable for detection and attribution studies to try and make it clear that things are changing. But this differs generally from the types of extremes required by the impacts community for design purposes, which are high impact region specific events. And so this sort of bottom up approach of taking extremes is actually different, and we have to have this conversation, and this project, Forewarned is Forearmed, is one space where we're doing that. Thanks.